Welcome to the presentation on systems of linear equations. So let's get started and see what this is all about. So let's say I had two equations now. The first equation, let me write it as 9x minus 4y equals minus 78. And the second equation I will write as 4x plus y is equal to minus 18. Now what we're going to do now is we're actually going to use both equations to solve for x and y. We already know that if you have one equation and it has one variable, it's very easy to solve for that one variable. But now we have two equations. You can almost view them as two constraints, and we're going to solve for both variables. And you might be a little confused. Boy, how does that work? Is it just magic that two equations can solve for two variables? Well, it's not, because you could actually rearrange each of these equations so that they look kind of in the normal y equals mx plus b format. And I'm not going to draw these actual two equations because I don't know what they look like. But if this was a coordinate axis, and I don't know what that first line actually does look like, we could do another module where we figure it out. But let's just say, for sake of argument, that first line, all the x's and y's that satisfy 9x minus 4y equals negative 78, let's say it looks something like that. And let's say all of the x's and y's that satisfy that second equation, 4x plus y equals negative 18, let's say that looks something like this. Right? So on a line is all of the x's and y's that satisfy this equation. And on the green line are all the x's and y's that satisfy this equation. But there's only one pair of x and y's that satisfy both equations. And you could guess where that is. That's right here, right? Whatever that point is, I'll do it in pink for emphasis. Whatever this point is, notice it's on both lines. So whatever x and y that is would be the solution to this system of equations. So let's actually figure out how to do that. So what we want to do is eliminate a variable, because if we can eliminate a variable, then we can just solve for the one that's left over. And the way to do that, let's say I want to eliminate, I feel like eliminating this y, and I think you'll get an intuition for how we can do that later on. And the way I'm going to do that is I'm going to make it so that when I add this to this, they cancel out. Well, they don't cancel out right now, so I have to multiply this bottom equation by 4, and I think it'll be obvious why I'm doing it. So let's multiply this bottom equation by 4, and I get 16x plus 4y is equal to, let's see, 40 plus 32 minus 72. Right? All I did is I multiplied both sides of this equation by 4. Right? And you have to multiply every term because it's distributive property and both sides. Whatever you do to one side, you have to do the other. And let me rewrite that top equation again, and I'll write it in the same color just so we can keep track of things. 9x minus 4y is equal to minus 78. Okay. Well, now, if we were to add these two equations, when you add equations, you just add the left side and you add the right side. Well, when you add, you have 16x plus 9x. Well, that equals 25x, right? 16 plus 9. 4y minus 4, that just equals 0, so that's plus 0, equals, and then we have minus 72 minus 78. So let's see, that's minus 140, 150, minus 150, right? We're just adding them all together. So we have 25x equals 150. Well, we could just divide both sides by 25, or multiply both sides by 1 over 25. It's the same thing. And you get x equals, that's a negative 150. X equals minus 6. There we solve the x coordinate. Now to solve the y coordinate, we can just use either one of these equations up at top. So let's use this one because it seems a little bit marginally simpler. So we just substitute the x back in there, and we get 4 times minus 6 plus y is equal to minus 18. And I'll go up here. 4 times minus 6, we get minus 24 plus y is equal to minus 18. And then get y is equal to 24 minus 18. So y is equal to 6. So these two lines, or these two equations you could even say, intersect at the point x is minus 6 and y is plus 6. So they actually intersect someplace around here instead. I drew these, the lines probably look something more like that. But that's pretty cool. No, we actually solved for two variables using two equations. Let's see how much time I have. I think we have time to do another problem. So let's say I had the points, and I'm going to write them in two different colors again. Minus 7x minus 4y equals 9. And then the second equation is going to be x plus 2y is equal to 3. Now, if I were just doing this just as fast as possible, I would probably multiply this equation times 7, and it would automatically cancel out. But that's the easy way. I'm going to show you that sometimes you might have to multiply both equations, and we're going to actually, not in this case. So actually, let's just do it the fast way, real fast. So let's multiply this bottom equation by 7. And the whole reason why I want to multiply it by 7 is because I want this to cancel out with this. So if you multiply 7, you get 7x plus 14y is equal to 21. Let's write that first equation down. Again, minus 7x minus 4y is equal to 9. And now we just add. This is a positive 7x. It just almost looks like a negative, though. Okay, so that's 0. 14 minus 4y plus 10y is equal to 30. Y is equal to 3. And now we just substitute back either one of these equations. Let's do that one. X plus 2 times y, that's 2 times 3. X plus 6 equals 3. So we get x equal to negative 3. That one was super easy. The intercept. I hope I didn't do it too fast. Well, you can pause it and watch it again if you have to. Okay. So these two lines intersect at the point negative 3, comma 3. Let's do one more. Hope this one's harder. I think it will. Okay, so it's negative 3x minus 9y is equal to 66. We have minus 7x plus 4y is equal to minus 71. So here it's not obvious. So what we have to do is, if we want to let's say we want to cancel out the y's first. What we do is we try to make both of them equal to the least common multiple of 9 and 4. So if we multiply the top equation by 4, we get, I'll do it right here. Let's multiply it by 4 times 4. We'll get minus 12x minus 36y is equal to 4 times 6, 240 plus 24 is 264. Right? I hope that's right. And we multiply the second equation by 9. So it's minus 63x plus 36y is equal to, let's see, that's 639. Those are big numbers, 639. Okay, now we add the two equations. Minus 12 minus 63, that's minus 75x. These cancel out, equals 264. So let's see, what's 639 minus 264? See, I do this in real time. I don't use some kind of solution thing or solution manual or something. Let's see, 13 and 5, 70. I don't know if I'm right, but we'll see. So this is, since it's actually the negative on the 639, this is minus 375. And I know that 75 goes into 300 4 times, so x is equal to 5, because 75 times 5 is 375. We just divided both sides by 75. So if x is 5, we just substitute back into, let's use this equation. So we get minus 3 times 5 minus 9y is equal to 66. So we get minus 15 minus 9y is equal to 66. Minus 9y is equal to 81. And then we get y is equal to minus 9. So the answer is 5, comma, minus 9. I think you're ready to do some systems of equations now. Have fun.